Hey guys, here's a promise. I'm going to do this free response question. It's a calculator problem. You know, it's number one, and you've got a region R, which is bounded by this curved line, which is log x, and this straight line, which is x minus 2. And they ask you to find some areas of volumes related to it. So the first thing I would do here, particularly because it's a calculator question, is I would punch this into y1 and this into y2, which I did already. You can see right there. And then you graph this thing, which I already did. And I had to mess with my window a little bit to get the picture so I could see the intersection points. So I think it was like -1 and 5 and like -3 and 4. I don't know, but you can just mess with the window. -1 and 4 and -3 and 4 seem to work. So you can just mess around until you get the right picture. And then it says find the area of R. So for areas, we can either do top minus bottom or right minus left. And since these things are given to me solved for y already, top minus bottom will be easier. And anytime I'm doing vertical lines, I want these y equals functions, so it's fine to do top minus bottom. But you're going to need to know these intersection points. And I kind of want to make this point. It happened once or twice on the tests. If I want to call it, so let's say I want to find that point. So I calculate my intersection. That's kind of a mess because the words first curve are like right over where the intersection point is. But as long as I get close, I think it should be fine. Intersection's like right down here somewhere. Just hit enter 3 times basically. So I get 0.15859 something, something, something. And -1.8414 something, something, something. And you can call this, you can if you write these down once, and you can call this thing A comma B, and then just use these numbers in your calculations, but you can write A every time. Some of you seem to not care about that, which is fine, but I'm going to do that. I'm going to call this number A, and I'm going to store it in A in my calculator, as we've done in the past. Well, that number is actually in my calculator, so I can use it. I can do the same thing. If I do the same thing for the other intersection, I get 3.146 ... and then 4. I think it's 61. I can't remember now. I can't even read my own handwriting. I did this earlier, so I'm just going to do it again. Yep. Huh. 3.146, 1.1461, blah, blah, blah. 1.146, blah, blah, blah. I'll call that C comma D, just so I'm going to put that X value into C. And I put it into C because I called it C here, and that's less confusing. So now anytime I write down A on my paper, I'm going to use A, and write down C, I'm going to use C. It kind of makes sense. So now the area of this region is top minus bottom, the integral of top minus bottom, which is log X minus X minus 2 X from A, which is this point, to C. Like these X coordinates, this is C comma D, and this is A, B right here. So from A to C. You could have done like A, C, and B, D. Some people like A and B to be the X's, but it doesn't make any difference. Anyways, you punch this in your calculator, you get 1.949 roundabouts. So that's A, and like a lot of the work that I had to do, I've done already now. I have these coordinates, which is good, and the functions are in my calculator already, so they're in Y1. I don't have to keep typing them in. So there's like kind of like a little prep work you do at the beginning, and then it makes these problems go pretty quickly. Find the volume of the solid generated when R is rotated about the horizontal line Y equals -3. So that's like down here somewhere. Okay, that's fine. This is clearly going to be a washer because the edge of the region is not the axis of rotation. The axis of rotation is horizontal, and there's no horizontal lines here at all. So I'm going to have washers, and I'm going to do I'm going to sketch out my little r. My little r is going to look like this because I start like it's like the smaller of the two line, the shorter of the two distances. This is the longer one. So the volume here is pi times the integral from A to C again, because I'm going left to right. These are x limits. Big R is top minus bottom, and that's log x minus -3. Minus -3 is +3. So this right here is big R squared. And little r squared is this lower curve minus that one. So that's x minus 2 minus -3. So -2 plus 3 is x plus 1 squared dx. This right here is little r squared. And then your calculator will do that for you. One thing I did when I first did this was I typed all this in and forgot to multiply by pi. So that's pretty common mistake. Don't do that. Then you get 34.198 or 34.199 if you want to round instead of just truncate. And now write but do not evaluate an expression that can be used to find the volume when r is shown. Okay, now I'm going around the y-axis. That's the trick here. So my new axis of rotation is the y-axis. So it's like a vertical axis, which means I got to solve everything for x and then do right minus left for my r's, my radiuses. And the solving for x is, to me, the part that would give you guys the most trouble, I would guess. I want to solve y equals x minus 2. For x is pretty straightforward. You just add 2 to both sides, and you get x equals y plus 2. But solving this for x makes you guys crazy. And when you have a log, to get rid of the log, so to speak, to cancel it out, you got to raise both to the e power. So you get x equals e to the y. And this, like I said, it's not going to make you guys that happy. So I'm going to erase these green and red lines. I'm going to do new ones. This was a point A, comma B. I'm going to erase that also. So I'm thinking about horizontal distances for my radii. And now if I start here, the first curve I run into is little r, that's this one. And the first curve I run into here, the second time the other curve is big R. So I got little r and big R and green and red. Those are r of y's now. So volume is the integral from, now it's at this point, it's like the smaller y, b to the bigger y, b. B to d of big R squared. Oops, I forgot the pi. Big R is right minus left, so it's y plus 2 minus 0, because the y-axis, it's a curve x equals 0. So y plus 2 squared minus this is e to the y minus 0 minus e to the y squared dy. And then you can stop. It says do not evaluate, so you don't have to evaluate. You could, I don't know why they didn't ask you to, just punch this in your calculator if you wanted to. But that's how you would do this problem. You got your standard area part A. You got your relatively straightforward washer method here around a horizontal axis for part B. And for part C, you got a washer around the vertical axis. So those are the 3 parts. We'll do more practice like this in class.